Welcome to today's lesson. So on today's lesson, we'll be looking at how to go about finding the empirical formula. But before we do that, let's actually understand the definition of empirical formula. So the definition of empirical formula is that it is the simplest whole number ratio of atoms in a compound. Okay, it is the simplest whole number ratio of atoms in a compound. So empirical formula, guys, doesn't necessarily show us the number of atoms found in that compound, but what it does instead is show us the ratio, as the definition indicates that it is what? The whole number ratio. It doesn't say that it is the formula that shows you the number of atoms in a compound. Okay, only shows you the ratio. That is the definition of empirical formula. And as you know, guys, it's very much important to memorize your definitions. How do you do that? You may sing it, you may just go through it over and over again. Watch this video every day if you have to, but just make sure that you understand this definition to the fullest. It is the simplest whole number ratio of atoms in a compound. That's what empirical formula is. Okay, now what we'll be doing next is finding the empirical formula through examples. So please hang tight for that and make sure that you understand thoroughly. And I hope you are also writing down everything that is being done here as you are watching the video on a piece of book, or rather on a scrapbook that you have. Okay, let's look at our first example. All right, guys, let's look at our first example. So it reads as follows. It says mercury forms a compound with chlorine that contains 73.9% mercury and 26.1% chlorine per mass. Calculate the empirical formula of the compound. So guys, this is how we should go about finding the empirical formula. The best way that I will advise you is by making use of a table. So you are going to draw a table as per what I'm going to show you now. Okay, so the first thing that you look at is the number of atoms you have, or we can say elements. In this case, we have two. We have mercury. Let me just highlight them. We have mercury and we also have chlorine. So those are the elements that we have. So our table means we'll have two elements. Okay, so let's draw our table. So our table will be as follows. We have a table like that, and then the first row will be the row that comprises of the elements. Okay, and because I have two elements, it means I should have two columns of elements. So on this first column here, I will write E. This E is for elements, and then on this second column I will have my mercury atom or element. So let me just increase my pen. So it's going to be Hg. That is the symbol for mercury. And then I will have another column. That column will be the column of chlorine. So I will write the symbol of chlorine, which is Cl. And then I will go to my second column. Second row rather. On my second row, I'm going to have the mass. So I'll write small m here. Okay, let me just fix that because I want to write a very small m, not too big. So I'm going to write my m there for mass, and mass is obviously measured in grams, so I'm going to write the unit there. Then here on this space, and this space, I'm going to write the masses of mercury and the mass of chlorine. Where am I going to get those masses? I will get them here. You see this percentage, that is my mass. So I'm going to convert this percentage to a mass, but I don't, me converting my mass doesn't mean that I'm gonna calculate or do anything special. No, all I'm gonna do is remove this percentage. Even for chlorine, I'm just going to ignore the percentage, take the values instead. Okay, so on these two columns, that's what I'm going to do. I'm going to write my masses. For mercury, it's going to be 73,9, and that is in grams. And then for chlorine, I'm going to have 26,1. Those are my masses. Then after doing that, I'm gonna go to my next row. On my next row, I'm gonna have my number of moles, and we know that number of moles is found by saying N is equal to small m over big M, where the small m is the mass and the big M is the molar mass. Okay, so that's what I'm gonna write here. And I know that my number of moles is measured in moles, so I'm gonna write the unit there. I don't have enough space, but I believe you get where I'm going with this. So once I've written this formula down, I am now gonna find my number of moles, and I will write that here and here. So let's find our number of moles. For me to find the number of moles of mercury, I will take the mass of mercury, which is 73,9, and divide that by the molar mass of mercury. The molar mass of mercury is going to be 201. Where am I going to get the molar mass of mercury, guys? I will get it on my periodic table. Then I will go to my calculator, say 73,9 divided by 201. What is that going to give me? It's going to give me an answer of 0,368. Then I'll come this side. For chlorine, find the number of moles of chlorine by saying 26 divided by 1, because this is my mass, divided by the molar mass of chlorine, which is 35,5. And the answer there, when I say 26,1 divided by 35,5, is going to be 0,735 moles. So that is what I'm supposed to do here on this row. Then after here, I'm going to move on to the last one. The last one being this one here. On this last one, guys, what I'm going to have is my ratio. So I will write R. Okay, I'm going to write R for my ratio. My ratio I get by doing this. I will look at my two answers, which are my number of moles. This is my first number of moles, 0,0368. The second one is 0,735. And then what I will do is to look at the one that is the smallest between these two. Which one, when you look at this example, is the smallest? The smallest is this one here. The 0,368 number is smaller than this one. So I will use this number to divide itself and this one. How do I do that? Let me just show you quickly. I will say 0,368 divided by 0,368. And what do I get when I say 0,368 divided by 0,368? I'm going to get 1. Then when I come this side and I say 0,735 divided by 0,368, what do I get? I get 1,99999. And because this is 1,9999, I'm simply going to round this off to a whole number. And if I do that, 1,999 should give me 2. So my ratio then will be 1:2. It's going to be 1:2. Once I have this, it means that I will have these numbers being written down at the bottom of these symbols. Okay, so here I have mercury. The symbol of mercury is Hg. So I will write Hg. Okay, let me just in fact go back a bit just to conclude. So I will conclude by saying that Therefore, my empirical formula, I'm just gonna write, let me just erase here. I'm going to say therefore my empirical formula is my symbols of mercury, which is Hg, and the ratio of mercury is 1, right, as we can see from here. So this number I'm gonna write at the bottom, but we know the story about 1. We never write 1, so I'm not gonna write anything here. But if it was a number bigger than 1, then yes, I was going to write it here, but in this case I will not write it. Then the second thing I'm gonna do is write the symbol of fluorine. What's the ratio for fluorine? It's 2, so I'm gonna write it here at the bottom. So this is the empirical formula of mercury and chlorine. Okay, it is HgCl2, and that is how you actually now go about finding your empirical formula. Okay, I hope you understand this. We'll do another example just to make this make more sense. All right. One important thing that I have to mention is, please guys, do make sure you like the video and subscribe to the channel, because it's gonna be helping you a lot. Thank you for watching and see you next time.